The solar system. You know that the Sun and the planets which revolve around it, along with their respective satellites and asteroids, form the solar system. The 8 planets of the solar system can be divided into 2 groups, inner planets and outer planets. Mercury, Venus, Earth, and Mars are the inner planets. Inner planets are also known as terrestrial planets, as they are rocky and dense, and their cores are made up of metals. Jupiter, Saturn, Uranus, and Neptune are the outer planets. Outer planets are large, with no solid surface. It is believed that they have a small, solid core and rotate relatively fast around their axis. Many planets of the solar system have satellites which revolve around them. The Earth has only one satellite, the Moon, but Jupiter has more than 63 satellites and Saturn has more than 56 satellites. We will begin our journey with a trip to the Sun, which is a star and is at the center of the solar system. The Sun's diameter is about 1,392,000 kilometers. 3/4 of the Sun's mass is hydrogen, and almost 1/4 of its mass is helium. The Sun also has some amounts of oxygen, carbon, and neon. The Sun is no different from all the other stars we see in the sky. Like the other stars, the Sun is a ball of burning gases and produces its own light and heat. Of the thousands of stars in the universe, the Sun appears the biggest because it is the nearest star to the Earth. It is at a distance of about 149.6 million kilometers. Light travels from the Sun to the Earth in about 8 minutes and 19 seconds. The energy of the Sun's light and heat supports all life on the Earth. All the planets and astronomical objects in the solar system are bound to the Sun by gravity. All planets of the solar system revolve around the Sun in a fixed orbit. The Earth takes about 365 and 1/4, that is 6 hours and 8 minutes, days to complete one revolution around the Sun. Planets also rotate on their axis. The Earth's axis is always inclined in the same direction at an angle of 23.5 degrees to the vertical. This inclination of the Earth's axis, together with the Earth's revolution around the Sun, causes seasons. The Sun's size is about 109 times that of the Earth. It is almost 99.86% of the total mass of the solar system. The Sun produces energy by a process called nuclear fusion. It turns large amounts of hydrogen into helium every second, creating heat and light in the process. That is why the Sun is very hot. It is around 6,000 degrees Celsius hot at the surface. Mercury, the closest planet to the Sun, is also the smallest planet in the solar system. Its diameter is just less than half the diameter of the Earth. Mercury completes one revolution around the Sun in only 88 days. Mercury takes 58 days to complete one rotation on its axis. During the day, Mercury's temperature goes above 400 degrees Celsius due to its proximity to the Sun. At night, the temperature drops down to minus 175 degrees Celsius as Mercury loses all its heat because it has almost no atmosphere to trap the Sun's heat. Let's go to the next planet of the solar system. A natural satellite, or moon, is a celestial body that orbits a planet or smaller body. The moon is the Earth's satellite. Mercury and Venus have no satellites. Mars has two. The Earth is the third planet of the solar system. It is the only known planet which supports life. The Earth is nearly 13,000 kilometers wide. It is the only planet in the solar system with water on its surface. Two-thirds of the planet is covered by water. The Earth's distance from the Sun, its atmosphere, and the presence of water on it make it ideal for life. Life is found in every little corner of the Earth, be it the tiniest bacteria or the largest animal. The Moon is about one-third the size of the Earth. It has no light of its own and reflects the light of the Sun. The Moon does not have any atmosphere. It also doesn't have any liquid water on its surface. During the day, it becomes very hot, but at night it is icy cold. The Moon revolves around the Earth and also completes one rotation on its axis in 27 days and 8 hours. This is why only one side of the Moon is visible from the Earth. The visible side of the Moon is called near side. In 1959, a probe sent back pictures of the far side of the Moon. Now, let's continue our space mission. Rotation of the Earth. All spinning objects have an imaginary line called an axis on which they spin. Look at this top. It seems as though there is a line running through the center of the top. However, when the top stops spinning, the line seems to vanish. The Earth too has an axis which passes through the north and south poles. The Earth also spins around its axis. Can you spot the difference between the Earth's axis and the axis of the top? The axis of the top is vertical, but the axis of the Earth is slightly tilted. It is at an angle of 23.5 degrees. The spinning of the Earth around its axis is called rotation. The rotation of the Earth always takes place in the same direction, from west to east. Do you know how much time the Earth takes to rotate on its axis once? The Earth takes 24 hours to spin around its axis once. Look at this ball. The side of the ball facing the torch receives light, while the opposite side remains dark. While the Earth rotates around its axis, only half of its surface faces the Sun. The portion that faces the Sun receives light and experiences day, and the portion in darkness experiences night. If the Earth did not rotate, the areas experiencing day and night would be permanently fixed. Do you know what the circle that divides the day from night on the globe is called? It is called the Circle of Illumination. When the Sun is overhead at any point on the Earth's surface, the time at that place is 12 noon. As the Earth moves from the west to east, the dark half gradually faces the Sun. This movement produces dawn and dusk, the periods of diffused light between day and night. The part of the day just before the Sun rises in the east is called dawn. The part of the day when the Sun sets in the west and there is still sunlight is called dusk. Can you give another word for dusk? Another word for dusk is twilight. When we are in a moving train, the objects outside, such as the trees and buildings, seem to be moving in the opposite direction. However, in reality, they are still while the train moves. Similarly, the sun's position is fixed. It is the earth that rotates from west to east. But to us, the sun appears to rise in the east and set in the west. The countries in the eastern part of the globe experience sunrise earlier than the countries in the west. Can you name the country known as the Land of the Rising Sun? The Land of the Rising Sun is Japan. Revolution of the Earth. The Earth moves around the Sun in a fixed elliptical path. The path is called its orbit. The Earth moves in its orbit at a speed of 30 kilometers per second. All planets also move around the Sun in fixed orbits. Each planet has a different orbit so that they don't bump into each other. The movement of the Earth around the Sun is called revolution. What is the difference between the Earth's rotation and revolution? The spinning of the Earth on its axis is called rotation, while the movement of the Earth around the Sun is called revolution. The Earth takes 365 days, 6 hours, and 8 minutes, approximately 365 and 1/4 days, to complete one revolution around the Sun. That is why a year has 365 days. Though the Earth takes 365 and 1/4 days to complete one revolution around the Sun, we take 365 days as 1 year. The remaining 1/4 days are added to the year after every 4 years. The year with 366 days is called a leap year. To which month in a leap year do we add the extra day? In a leap year, we add the extra day to February. The Earth's axis is always inclined in the same direction at an angle of 23.5 degrees to the vertical. This inclination of the Earth's axis together with the Earth's revolution around the Sun causes seasons. The equator divides the Earth into two halves known as hemispheres. In position A, the northern hemisphere is more tilted towards the Sun than the southern hemisphere. Thus, in this position, the northern hemisphere is hotter and experiences summer. Meanwhile, the southern hemisphere experiences winter. In position B, the sun's rays fall directly on the southern hemisphere, while they fall on the northern hemisphere in a slanting manner. What season will the southern hemisphere have in position B? When the Earth is in position B, the southern hemisphere will be hotter and it will be summer there. Meanwhile, the northern hemisphere will experience winter. Equi means equal and nox means night. Equinox is the time when all places on the Earth have equal duration of day and night. Each year, on 21st March, the spring equinox, the sun shines directly on the equator. Again on 23rd September, the autumn equinox, the sun shines directly on the equator. Sol means the sun. Solstice means the standing still of the sun. Solstice is either of the two times of the year at which the sun reaches its highest or lowest point in the sky at midday. In the northern hemisphere, June 21st is the longest day, and December 21st is the shortest day. spring tide and neap tide. A rise and fall of ocean waters that occurs twice daily is called a tide. Tides are caused by the gravitational pull of the sun and the moon. The moon, being much closer to the Earth than the sun, exerts a greater force of attraction. The rise in the level of water is called a high tide. The fall in the level of water is called a low tide. When the sun, moon, and the earth come in a line, as on a new moon or a full moon night, the tides are higher. These tides are called spring tides. When the sun and the moon make a right angle with the earth, as on a half moon night, the force of attraction gets balanced and the tides are not so high. These are called neap tides. Block mountains. Block mountains are formed when cracks or faults occur in the Earth's crust, and the land between the cracks sinks, leaving upstanding blocks on either side. Block mountains are also known as fault block mountains. You can make your own fault block mountains using a long eraser. Take a long eraser and use a pencil to draw fault lines on it. Use a cutter or blade to cut the eraser across the lines drawn earlier. Place the pieces of the long eraser together to make the eraser whole again. Apply a little pressure on the corner pieces and lift the whole eraser above the table. Slowly pull the corner pieces apart and you can see how the land in the middle of fault lines subsides and block mountains are formed on either side. The edges of such mountains are steep and the surfaces are almost level. An example of block mountain is the Vosges in Europe. The marble rocks at Jabalpur are an example of block mountains found in India. Fold mountains. Fold mountains are formed when the layers of the Earth's crust are folded by compression. To make your own fold mountains with the help of some hand towels, lay 10 hand towels on a flat surface and place 2 shoe boxes on each side like shown here. Push the shoe boxes towards the center as shown. This activity shows us how fold mountains are formed when forces move towards a common center. The Aravalli Range in India is an example of old fold mountain. It was formed over 250 million years ago and has gentle slopes and low altitude due to weathering over time. The young fold mountains were formed comparatively recently, about 25 million years ago. These mountains are rugged and lofty. They comprise the world's highest mountain ranges like the Alps of Europe and the Himalayas of Asia. Volcanic mountains. Volcanic mountains are built when molten lava, ash, cinder, and dust from deep inside the earth come out on the surface through cracks in the earth's crust and accumulate. A magma chamber is a reservoir of magma within the earth's crust beneath a volcano. The viscous magma traps hot gases within it, which are released suddenly during an eruption. The magma, originally oceanic crust, also contains large volumes of water, which in its gaseous state of steam increases the pressure within the vent. The release of gases and steam under high pressure increases the likelihood of a violent eruption. The opening through which lava and other materials come to the Earth's surface is called a vent. The funnel-shaped depression at the top of a vent is called a crater. The rock plug left below the crater from a previous eruption blows off violently, creating a hail of ash and rock. Violent eruptions result in the collapse of the top of the cone. Secondary or parasitic cones are formed on the sides of the volcanic mountain. The cone's steep sides are formed after the sticky acid lava pours slowly down the side of the cone and cools quickly. Each eruption first produces rock fragments, which are later covered by lava, forming alternate layers on the volcanic mountain sides. You can make your own volcano using some mud, a small plastic cylindrical container, red and yellow food coloring, liquid dishwashing soap, baking soda, and a glass of vinegar. Make a volcanic mountain out of mud. Make sure you have left the center hollow to fit your plastic container. Insert the plastic container on the hollow center of the volcano at the top. Add 2 spoonsful of baking soda. Based on the frequency of activity, volcanoes are classified into 3 types: active, dormant, and extinct. Active volcanoes are the volcanoes that have shown signs of activity in recent times. There are around 700 active volcanoes in the world, including some that are under the sea. Dormant volcanoes are the volcanoes which have not erupted for a long time. There is always a danger that a dormant volcano may suddenly erupt. Extinct volcanoes are volcanoes that scientists believe have finally died. Gradually, the volcano is eroded, and in some places, the only evidence of a volcano is the remains of the hard plug that filled the vent of the volcano. Erupting volcanoes pose many hazards. Ash cloud is fatal to all the life forms in the surrounding areas of the volcano. It is often blown high into the atmosphere during the eruption and then carried to a considerable distance by the wind. Pyroclastic flow, or a hot avalanche, a glowing cloud of hot ash, rocks, steam, and gases, moves at a speed of over 300 kilometers per hour. It causes havoc in the areas where it spreads. Lahar, or a mud flow, melted snow or water from the crater lake mixed with volcanic ash, follows river valleys at great speeds, causing damage to life and property along its course. Lava is usually the last element to erupt and rarely flows far away from the volcano. It is of little danger to people living in the vicinity. The soil produced as a result of the weathering of volcanic rock is very fertile. People live ever closer to volcanoes because of higher yields from the fertile soil, putting themselves at high risk. Rift Valley Formation. A rift valley is formed as a result of the sinking of a portion of the crust between cracks on the surface of the Earth. There are three stages in the formation of a rift valley. Stage 1. Layers of rock are subject to tension or stress. Stage 2. Faults or cracks develop in the layers and the central block begins to subside. Stage 3. After subsidence, a depression with steep sides is formed. This is a rift valley. You can make your own rift valley using a long eraser. Take a long eraser and use a pencil to draw fault lines on it. Use a cutter or blade to cut the eraser across the lines drawn earlier. Place the pieces of the long eraser together to make the eraser whole again. Apply a little pressure on the corner pieces and lift the whole eraser above the table. Slowly pull the corner pieces apart, and you can see how the land in the middle of fault lines subsides and a rift valley is formed. The Great Rift Valley of Africa is a special physical feature of the Southern Plateau. It is a long, narrow valley formed as a result of vertical cracks that developed because of the movements within the Earth. It extends for a total distance of 5,000 kilometers from Lake Malawi through the Red Sea and the Gulf of Aqaba to the Dead Sea in Jordan. Many freshwater lakes like Malawi, Rudolph, Tanganyika are found here. The three-tier structure of tropical rainforest. Tropical rainforests are generally found in the regions between the tropics of Cancer and Capricorn. which experience high temperature and receive abundant rainfall. The combination of high temperatures, heavy rainfall, and a continuous growing season encourage high rates of biological activity, making tropical rainforests the most luxuriant vegetation system in the world. The vegetation consists mainly of hardwood trees and broad-leaved trees. Although the trees are deciduous, the rainforest has an evergreen appearance as the continuous growing season means that when one species of trees is shedding leaves, others are growing new leaves. Trees grow to different heights, giving an impression of a three-tier formation. Typically, four main layers, each with different plants and animals adapted for life in that particular layer, constitute a tropical rainforest. These layers are forest floor, understory layer, canopy layer, emergent layer. Forest floor. The floor of the forest is marshy and covered with bushes, creepers, and dense undergrowth. Understory layer. The second layer consists of smaller, young trees and leafy herbaceous plants that tolerate low light. Canopy layer. The third layer is the canopy layer. The broad, irregular crowns of these trees form a tight, continuous canopy, 60 to 90 feet above the ground. The branches are often densely covered with other plants and tied together with vines. Emergent layer. The giant trees that thrust above the dense canopy layer and have huge mushroom-shaped crowns form the emergent layer. These trees enjoy the greatest amount of sunlight and endure high temperatures, low humidity, and strong winds. The Zaire Basin in Central Africa is one of the most extensive areas of tropical rainforest in the world. The hardwood trees found in rainforests of Africa are valuable for making good quality furniture as the wood is heavy. However, it is difficult to exploit resources of the African forests because the forests are dense and trees do not grow in pure stands. Despite its luxuriant appearance, the rainforest is a fragile environment, as its survival relies on a rapid recycling of nutrients. Deforestation breaks the nutrient cycle, resulting in the soils becoming infertile, and the loose soils are washed away easily. Once the soils wash away, the forest can never again replenish itself to its former state. It is important to conserve rainforests as they are home to a variety of species of trees and animals. They also play a crucial role in regulating the global climate. Convectional rainfall. In regions closer to the equator, the rate of evaporation is very high. As the sun heats the ground, the air above it gets heated and starts rising in the form of convection currents. As air rises, it expands and cools. The cooling causes condensation, which results in heavy downpour. This rain is accompanied by thunder and lightning, and since it mostly occurs around 4 p.m., it is often called the 4 o'clock showers. Due to the hot weather in Costa Rica, the country experiences heavy convectional rainfall. Convectional rainfall is also experienced in Europe during the summer season. Cyclonic rainfall. Cyclonic rainfall is caused when warm and cold air masses meet at a front. As cold air is denser, it remains close to the ground, while the warm air rises above it. As it rises, it expands and cools, resulting in rainfall. Cyclonic rainfall mostly occurs in temperate and tropical regions. In the tropics, the trade winds blowing towards the equator meet at the Intertropical Convergence Zone, ITCZ. The air is forced to rise, and along with strong convection currents, it forms the heavy afternoon thunderstorms associated with the equatorial climate. Monsoon. The word monsoon is derived from the Arabic word mosim, which means season. The Arabs used the term to describe the seasonal winds of the Arabian Sea. The term monsoon is now used for a seasonal change in the direction of the prevailing or strongest winds of a region. These winds change the direction in which they blow, from the sea to land and vice versa. Monsoons cause both dry and wet seasons throughout much of the tropics. The monsoons are most often associated with the Indian Ocean and determine the climate of most of India and Southeast Asia. Monsoons always blow from cold to warm regions. When the sun shines directly over the Tropic of Cancer, or 23.5 degrees north, Central Asia experiences summer. The air above the land gets heated, rises, and creates a low pressure region. Owing to the peninsular shape of India, the southwest monsoon winds are divided into two branches: the Arabian Sea branch and the Bay of Bengal branch. The Arabian Sea branch brings rain to Kerala. It is the first state in India to receive the monsoon showers in the first week of June. The, Ara- the Arabian Sea branch brings rain to Kerala. It is the first state in India to receive the monsoon showers in the first week of June. The Arabian Sea branch is stronger and causes heavy rainfall on the western sides of the Western Ghats. The Arabian Sea branch, after spending its moisture on the Western Ghats, advances over the Deccan Plateau, where the interiors of the southern peninsula hardly receive 50 to 60 centimeters of rainfall during the rainy season. Meanwhile, the Bay of Bengal branch travels over the waters of the Bay of Bengal, collecting moisture on its way. The heavy moisture-laden winds bring heavy rainfall to northeastern India. Then the monsoons are forced to take a turn towards the northwest along the curve of the Himalayas, causing rainfall over the northern plains. The Himalayas block the Bay of Bengal branch from crossing over to China. By the time the monsoons reach northwestern India, the moisture has been spent and the winds become dry. As a result, this part of the country receives scanty rainfall. When the sun shines directly over the Tropic of Capricorn, or 23.5 degrees south, Central Asia experiences winter. The air above the land is cold and heavy, and a high-pressure region is created over land. Meanwhile, the air above the surrounding water bodies is relatively warmer and creates regions of low pressure over them. As a result of the change in the positions of high-pressure and low-pressure regions, the winds change direction and start blowing from the land to the sea. Such winds are called winter monsoons or retreating monsoons. The dry winter monsoons blow from the northeast and are also called the northeast monsoons. They last from November until February. These winds, being cool and dry offshore winds, do not bring rainfall unless they cross water bodies before hitting land. They bring rainfall to some parts of Tamil Nadu after picking up moisture from the Bay of Bengal. Relief or orographic rainfall. Sometimes moisture-bearing winds are forced to rise because of the presence of a physical barrier, such as a mountain. Such winds expand and cool as they rise up the slope of the mountain or plateau, and on further cooling form clouds. When saturated, these clouds give rain. This rain is called relief rain because it is caused by the relief feature coming in the way of the wind. The side of the relief feature that faces the moisture-bearing winds is called the windward side. This is the side that receives most of the rainfall. The other or opposite side is called the leeward side, which receives very little rainfall as the winds descend and get warm. This leeward side is also often called the Rainshadow Region. In India, the southwest monsoon winds are forced to rise along the windward side of the Western Ghats. So, the regions along the west coast of India receive heavy rainfall. The Deccan Plateau lies in the rain shadow or leeward side of the Western Ghats and is therefore a dry area. Planetary winds. Planetary winds are also called permanent or prevailing winds as they blow the year round in the same regions. There are three types of planetary winds: trade winds, prevailing westerlies, and polar winds. The trade winds blow from the subtropical high-pressure belts, horse latitudes, to the equatorial low-pressure belts, doldrums. They are constant in strength and direction, and therefore the name trade, which in Latin is trado, which means constant direction. These winds blowing towards the equator from 30 degrees north from the northeast in the northern hemisphere and from 30 degrees south from the southeast in the southern hemisphere are known as the northeast trade winds and the southeast trade winds respectively. They are also called the Northeast Trades and the Southeast Trades. William Ferrel, an American meteorologist, developed Ferrel's law to explain the direction of the northeast trade winds and the southeast trade winds. It states that a body moving over the surface of the Earth will be deflected to its right in the northern hemisphere and to its left in the southern hemisphere. This happens as a result of the Earth's rotation and applies particularly to oceanic and air movements. The prevailing westerlies blow from the subtropical high-pressure belts, horse latitudes, to the subpolar low-pressure belts, between 30 and 60 degrees north and south. They are not constant in strength and direction. These winds are also known as southwesterlies in the northern hemisphere and northwesterlies in the southern hemisphere, based on the direction from which they blow. The prevailing westerlies blow from the subtropical high-pressure belts, horse latitudes, to the subpolar low-pressure belts, between 30 and 60 degrees north and south. They are not constant in strength and direction. These winds are also known as southwesterlies in the northern hemisphere and northwesterlies in the southern hemisphere, based on the direction from which they blow. In the absence of land masses, the westerlies become very strong, especially between 40 degrees and 50 degrees, and are called the Roaring Forties. The polar winds blow from the polar high-pressure belts to the subpolar low-pressure belts. Their direction is variable in the northern hemisphere, but more regular in the southern hemisphere. These winds are known as the North Polar Easterlies and the South Polar Easterlies in the northern and southern hemispheres, respectively. In an artesian basin, a layer of porous or pervious rock lies between two layers of impervious rock and acts as a reservoir. The rainwater that seeps underground is trapped in the previous layer and forms an aquifer, a layer of rock capable of holding water and allowing it to pass through. When a well is bored into the aquifer, the water which is under pressure gushes out spontaneously. This well is called an artesian well. It seems that this type of well defies gravity because the water finds a path to the open air after the pressure that builds up between layers of rock gets relieved. The water, while passing through porous rocks, as it seeps into the earth to reach the aquifer, gets naturally filtered. This makes it a valuable source of underground water. The central lowlands of Australia are a rainless, flat, low-lying area between the East Highlands and the Western Plateau. They extend from the Gulf of Carpentaria in the north to Encounter Bay in the south, forming the world's largest artesian basin.